All right, so we'll go ahead and get started. Welcome, everyone, once again to the seminar series for AI-SDM. It's great today that we have with us one of our many rising stars in the Institute, Valerie Chen, who is a PhD student here at Carnegie Mellon in the Machine Learning Department. She's advised by Amit Talwalkar and also collaborates with a number of faculty here in the Institute as well. And her interests are in principled design of human AI teams. And I will switch screens here as we welcome Valerie here to the podium.
Hard doing.
There we go. You're all set.
Great, thank you. Thanks everyone for joining on Friday afternoon and on Valentine's Day. Wait, I brought Valentine's chocolate. Well, I didn't realize there would be such a extensive array of food, but if anybody asks questions who are in person, I guess you can.
Oh, and not messing around either. Yeah.
I wanted to be on theme, so, but in any case, there's plenty of food there. Yeah, thank you both for organizing. So yeah, today the topic of this talk will cover a lot of my work relating to human AI interactions. And yeah, it would be very interesting to discuss later, what are other people working on potentially related to this space and thoughts on how to design effective human AI interactions in what I'm calling an evolving AI landscape. Let me make sure I can. Okay, so yeah, I guess I was already introduced, but maybe the thing I wanted to point out is I really think of myself, as probably many of you do, as an interdisciplinary researcher. So want to draw from and think about techniques from different fields like HCI, ML and NLP, and so on, despite just having one home department. And so to motivate this talk, we'll go through a few different examples to start with. So there's clearly an increasing adoption of AI tools in practice. So, things that might canonically come up are, using like risk scores where, or models helping with making predictions. And so one concrete example that will come up later in this talk is, for example, in practice, fraud analysts might not want to review entire transactions by themselves. Can an AI be helpful and brought into the loop in terms of scoring each transaction and informing what an analyst decision might be? So this is an example of more of like a canonical, like predictive decision-making setting. But as the title suggests, there's sort of different like workflows at play. So more recently, with all this discussion about generative AI, people are increasingly using AI tools that not just output, like one single number, like they're probably generating different pieces of text, might be code, people are interested in like you're improving like all kinds of applications. And so one that we'll chat about later in terms of like one concrete like grounding example will be for coding, where many of you probably write code not on your own anymore, but with the use of various tools like GitHub Copilot. Some of you might have heard of things like Cursor and so on. But for those who maybe still write code on their own, what many of these tools will do is like suggest to you different snippets of code, or you can chat with a model about your repository. And so lots of developments in this space. And if you're embedded in sort of this like research space, you probably know a lot of people are talking about things like agents. So how can we think about interactions for agents down the line? I won't really talk too much here, but hopefully we'll be able to motivate why some of the considerations that I'm bringing up today in terms of some of the other AI tools that do exist, like might also be important to consider when we're building like more agentic workflows. And here, what I'm referring to is with agents will be things that actually potentially can take actions on behalf of users more than just like generating more outputs. So with this sort of evolving AI landscape in terms of like, there's all these different kinds of tools at a person's disposal, how do we think about like ways to design interactions for them? And just maybe like generically, we'll use like a neural network to refer to AI models like throughout this talk, but if I'm talking about something more specific, I'll try to like change the picture. Okay, and so what is the goal of actually introducing AI tools and building effective interactions? And one sort of term that has come up in the literature is something called complementarity. And so what you want is not just to include AI for fun, but rather like you want to compare to, does building human AI interactions do better than, for example, having models act on their own? But maybe even more importantly, does this outperform or, and by whatever metric we care about across different use cases, having humans making decisions on their own? So for example, writing code with Copilot should ideally enable you to write better code or write code more quickly than just you writing code on your own. But oftentimes this is unfortunately not yet the case. So we'll see different headlines like Gen AI convinces doctors that they're wrong, even though they're right. So you'll have like experts who might be falsely relying on AI outputs. Many of you probably have seen, like lawyers overlooking the use of hallucinated cases when writing their legal briefs with ChatGPT. And, there's definitely concerns that even I have seen talking to developers about how coding with these kinds of tools might introduce errors that are hard to find or potentially introduce like software vulnerabilities and so on. And so a lot of these headlines talk about, Gen AI applications, but, you can think about how many, I think RT raised her hand, but I don't, if you want to.
Yeah, hi, Valerie. If it's okay, can I just ask a quick clarifying question?
Yeah, go for it.
So would you also be considering comparison against like human teams, as in like there could be another lawyer who could convince the other lawyer that they are incorrect, even if they were correct, and vice versa?
Yeah, that's a good point. Typically, at least in a lot of the works that I've been a part of and in the literature, people don't compare to human teams, but I think in a lot of these settings that you're talking about, it actually is a very valid baseline, like doctors working together, despite a lot of the experimental setup actually just being studying like one individual decision maker. So definitely room for like expanding the set of comparisons that are done. So I guess the TLDR is I won't really touch on that here in this talk, and it hasn't been used as a baseline really in like the broad set of literature, but I think could be applicable in different scenarios. Maybe not all of them, for example, like with this coding one, like you usually write code on your own, but there's definitely discussions about like whether or not the metrics like actually capture like the full like software development life cycle.
Thank you.
Mm-hmm. Yeah. So definitely there are potentially some simplifying assumptions. So in terms of how these tools are actually used in practice, but hopefully we'll get a little bit closer to looking at real workflows than what some prior work have done. So yeah, I guess generally the question that I'm interested in is like, how do we design these effective interactions? And my hypothesis is that, there are kind of two sources of problems potentially in this like simplified workflow that I'm talking about here, where one of them is, I have nebulously put this like plus sign between human and AI, as is illustrated in a lot of existing work. And so somehow we're assuming that given AI outputs, that the human will know what to do with it. But as we'll see, this might not necessarily be the case. And I also put this, you know, somewhat ill-defined greater than sign. We don't really talk about yet a specific metric, but you know, if you're familiar with, you know, how evaluations are done in a lot of research applications, they may or may not actually reflect the real world use case. And so also talk about how we might kind of move towards that later in this talk. And so this talk will explore kind of two solutions, one looking at, you know, how we can think about designing new interaction mechanisms, the second on developing new evaluation paradigms. And hopefully we'll try to ground this in some of the like different studies that I have done, and the takeaways will also apply to you know, other use cases or domains that many of you all are interested in. And my hope is that by thinking about ways to propose new interaction mechanisms, it can also inform evaluation, and then findings from evaluation and vice versa tell us about what kinds of interaction mechanisms might be most useful. And so my talk will kind of be structured into like these two halves. All right, so first talking about interaction mechanisms, maybe to motivate why this kind of matters. Well, let's revisit briefly this fraud analyst example, where their job is to, given this like dashboard of information, you see, you know, for example, there are different transaction details and so on. Oh wait, there's more. You have to look at, you know, different information about like the user's like payment, their card details. Oh wait, there's even more things to look at. You know, you have information about like the customer billing, like where people live, up to, you know, like thousands of features that somebody might be perusing to try to quickly make a decision about whether or not this like credit card transaction was fraudulent. You know, they care about like making, and if they, you know, miss out on a transaction, like, you know, you're letting somebody who's like a thief like get away with this like, you know, whatever purchase that they were trying to make. And so what these like tools are doing is, you know, giving like a score, taking in all of these like features and scoring, for example, like this transaction on, you know, like a scale of, let's say, like up to like 800 in terms of, you know, how likely is this to be like a problematic transaction? And the analyst can take that into account when like ultimately deciding whether or not to like approve or decline or potentially escalate this like transaction that they're looking at. Now, obviously, the first question that they might ask is like, well, why is this 531? What am I supposed to really do with this information? And so hopefully putting yourself in this analyst's shoes, it's really important to think about how like somebody would actually be using the like AI recommendations that they're getting. So obviously there's a huge space of like what you might actually do to be able to better bridge like how humans are using like model outputs. And for this portion of the talk, I'll focus on one that a lot of people in the literature have been interested in, which is explaining what the model is doing. So like model explanations or like explainable AI and so on. But if you're interested, I've done a little bit of work on other things in terms of studying how people might use models. So why explanations? They're really people hypothesize that, you know, they might enable better decision making. So for example, instead of being fraud analysts, let's just like come up with a maybe more toyish example to look at for the sake of discussion right now. Let's say I'm trying to predict how much money somebody makes given these features. Not super realistic, but is a task that a lot of people have looked at in prior, especially like HCI studies. And, you know, as the quote unquote decision maker, I need to decide whether or not this person makes more or less than $50,000. And the model is telling me that I am, or the model thinks that for these features, the person's making below $50,000. And so what people have been looking at in terms of a way to explain why below $50,000 is to show something called feature-based explanations, which without currently getting into the details of how they're computed, basically assign some weight to each feature as a way to tell the user, like if it's like in terms of the magnitude or the like direction of this explanation, how to interpret like whether or not the model thought that this feature positively or negatively was influenced to make the final decision. And like a larger bar means that like this feature was like weighted a bit more in terms of the decision. And this can, apply beyond more like tabular settings to text, like you can highlight, like which tokens or words like were more, influential, quote unquote, in terms of predicting whether or not this like biography was, like this for this current text snippet, the model is predicting that this bio is one of a professor and not, one of these other options that we have. And so many of you might be familiar with different ways of computing explanations. So potentially like computing a local approximation, which is what LIME does, is one way. But there's all kinds of other methods that have been proposed by like the ML literature to be able to explain a model prediction at a certain point. So there's game theoretic approaches, gradient-based methods, and so on. But what I want to argue is that in practice, what we actually care about is not these different notions of faithfulness or like ways of theoretical methods of computing explanations. What we care about is how decision makers actually use these explanations. So if I give you like an explanation from LIME or something else, how does that actually impact like the downstream decisions or like, predictions that you make? So we actually did some evaluations to understand the usefulness of these various like popular methods. So working with this startup called Feeds AI to actually evaluate explanations with their analysts. And so instead of looking through a bunch of like hundreds of different features per transaction and trying to figure out what's going on with this model score, we picked like the top, K features and then show like if it positively or negatively influenced the model. Similarly, we worked with Nihar to explore potentially what explanation might look like in terms of helping ACs do paper matching in the like peer review process. And so what I won't get into detail here, but the sort of general takeaway was when we're applying these like, various popular methods like LIME or SHAP in these settings and comparing them to baselines, though we do not have like the very interesting one that I already mentioned earlier of, for example, just having humans making decisions alone or looking at just the model score or even like the model only baseline, which is not necessarily applicable in practice. Like we don't really see benefits in terms of having explanations. In fact, people are usually just more confident in terms of their decisions, though it does not necessarily lead to better outcomes. And so the part that I was really interested in is understanding actually like, how are people using this information that they're getting to be able to determine whether or not they want to rely on what the model is saying, right? And one interesting feature of this that I was interested in is that all of these examples that I've been talking about, for example, with the fraud analyst and so on, these are people who could certainly make decisions on their own. They're very capable and like have extensive background in the domain that they're working in. And so how are they integrating those types of quote unquote intuitions with what the model is saying and what the explanation is saying? And so here in this study, which I'll talk about in a little bit more detail, we actually try to understand how are people using existing explanations as a way to hopefully inform how we can design better interaction mechanisms in the future. Okay, so in terms of actually understanding, answering the question that I just motivated, we want to apply, or we applied what we're calling a mixed methods approach. And so in many prior studies, people just showed people different kinds of explanations. They measured decision outcomes, and then, we're like, oh no, the explanation doesn't actually work. And so what we did here is we not only measured what kinds of decisions people made, but also asked them to talk out loud as they're looking at the different pieces of information that we're showing them. And so this helps us understand how are they integrating things that they already know with what they're seeing from the model. And so this is the think aloud portion of the study. So for example, going back to this toy example of predicting how much money somebody makes, perhaps if I was a participant in the study, I would, immediately I would say oh, I noticed that the model says the number of hours worked per week, and that's or places a lot of emphasis on the number of hours worked per week in terms of making its prediction, and somehow it's very negative. But I disagree with this because I know electricians, which is the occupation of this person, who actually makes a bunch of money and they don't work a lot of hours. And so that's one way we can see in practice, how somebody might reconcile information that they see from the explanation with things that they know based on their intuitions. And for this task, we didn't, or for the study, we didn't actually recruit people who were domain experts, but I think it would be an interesting study to potentially do so. But here we just looked at, this toy income prediction task, and also this biography classification task to be able to see how some of these reasoning processes might be similar or different in terms of task and data formats. And we identify sort of 3 key types of intuitions and through this study, and hypothesize ways in which the way we're presenting feature-based explanations may or may not actually align with these intuitions. So for example, when I show you a task to make a prediction about, you have some intuition given your prior expertise or knowledge about what the decision might be. But what we see is that when you're actually showing people feature-based explanations, especially when you're highlighting keywords or things like that, it disrupts people's formation of their natural intuition. So immediately, if I show you, an explanation overlaid on this text, you're drawn to certain keywords that are highlighted by this explanation, which maybe you wouldn't have focused on if you were just to look at a clean version of the text. And I guess we also see this for the bar charts, though to a slightly lesser extent. And the second type of intuition that we notice is that people have intuition about the features that are used in the explanation. So what we see is that, in the example I mentioned earlier about the number of hours worked by an electrician, I have some notion of how much that feature should play into the decision, or how important it should be. And what we find is that people tend to get caught up about this relative size of importance between what the model says in the explanation versus what they might believe themselves, and use that as reasons to agree or disagree with the model, even though potentially they would have made the same decision as the model if they sort of didn't go through this reasoning process. So this introducing this explanation can potentially mess up your the way you're reasoning about what the decision outcome should actually be. And finally, people try to look for these additional pieces of information as ways to understand limitations about the model. And so I'll show you an alternative kind of explanation in a bit. But for these common feature-based explanations, people tried to look at are there more bars going to the right or versus to the left as a way to try to generalize that as a reason for whether or not the AI is reliable or consistent with its predictions, even though in terms of the actual data points that we looked at, there was no strong correlation. So in this study, we also looked at an alternative form of explanation, which is less used in practice, essentially for a few different reasons. But for the purpose of the study, we were able to also look at this to understand how these different forms of intuition played in, which is we just did something super simple, which is computing two nearest neighbors of the current instance. So for each of these two neighbors, we show not only the model's prediction, but also, because they come from the training set, what the actual ground truth solution was. And so what I mentioned earlier about, trying to intuit something about the model's limitations, this was actually really helpful for people to do that, because they at least were able to see two similar examples and try to reason about whether or not the model was right or wrong. And so, for example, in this case, for both of the similar biographies, you will see that the model prediction differs from the actual profession. So like differing from the ground truth solution. And so people will notice that and potentially pay more close attention to the current bio that they're asked to evaluate. And at least on, the two different tasks that we looked at in the study, we do see better performance and more, what we call appropriate alliance on the model and explanations when we show people nearest neighbor explanations as opposed to the more common feature-based ones. Okay, so we also more recently have tried to summarize some of the potential takeaways about evaluation and things like that for broader audiences, like in science, more like for a scientific audience, just because there is very broad interest in terms of applying these explanation methods. So if maybe that aligns with your background, I would encourage checking this work out. But as a quick summary of this first half, I think it's super important to think about, who the real users are for these various downstream tasks and to evaluate in those contexts whenever you're trying to propose new ways for people to interact with models, and thinking about ways to design interactions that don't induce over-reliance, and maybe further to think about from the user perspective how intuition, your various domain knowledge or expertise will impact how people process all of these different kinds of information that the model is showing. Okay, cool. So yeah, hopefully those are some somewhat general takeaways that you can also take and apply to whatever domains and use cases that you work on. Now shifting gears a little bit to talk about evaluation, which I think is super, super important with a lot of new workflows that people are using today. So this was slightly less of an issue with some of these predictive contexts that we were talking about before in terms of, it's hard to potentially get ground truth answers and in terms of what the right intervention or decision should have been, but you can at least construct data sets and measure, the correctness or false positive rates and so on of whatever intervention was made. But now we'll sort of shift gears and talk a bit more about Gen AI context, where I think evaluation is a bit less clear-cut. So how have people been doing evaluation so far? There has been a lot of usage of, static benchmarks, which have kind of been the cornerstone of how people do evaluation. So, ImageNet was, one of the OG benchmarks that people look at more recently with large language models, things like MMLU. But as you can see with all of them, many of these benchmarks get saturated over time. And, it's not clear if hill climbing on these benchmarks alone will produce models that will be effective for humans to use. But, obviously the, nice benefit of these various benchmarks is they're quick and easy to use. So whenever you have a new model, it's easy to run it through these various questions that are defined in the data set to be able to get a sense of like what this model's capabilities are. And as I mentioned earlier, one of this use cases that I've been very interested in was for code models. And benchmarks are sort of no stranger for people working on like code generation. So many of you might have heard of things like human eval or apps. But there's all kinds of benchmarks out there for evaluating coding capabilities for whether it's like different kinds of different languages or different types of like competition problems and so on. But maybe if for those people who haven't actually looked at these data sets in detail, what they usually look like is the model's asked to complete a function. So let's say, given this function definition and docstring, which is like find max, and then, you need to write a function that accepts a list of strings and so on. It even tells you, potential like edge cases to look out for, though that doesn't always happen. It might even show you some examples of what like inputs and outputs should be for this given function that the model has to complete. But, in terms of how models are actually used in practice, as, coding assistants, I personally, speaking for myself, have never written a docstring that looks like this, to this like sort of extent. So there's sort of like a natural question for me of like, how well do these benchmarks actually capture the types of use cases that we see in practice? So in practice, like as I mentioned earlier, many of what the real world use cases look like are these actual tools like Copilot or Cursor and so on. And increasingly, like there's a lot of adoption of them, like, with like millions of users who are actually coding with Copilot. But what we're interested in is like, do these benchmark performance actually translate into how well users can actually use these tools in practice? And so in this recent work, we actually tested this hypothesis by running a study where people write code with models of different performance in terms of like, well-known benchmarks. And to do this, we had to create like an interface that people could use and plug in different kinds of models in the back end. So for example, here you can see like in the gray text, there's, the next few lines of code that's like generated by whatever models in the back end. So we found like the interface can provide like code completion suggestions. We also looked at benchmarking how well like these different models can like, be used as like chat assistants. And this is sort of like part of this like broader pipeline that's now open source. If you're interested in like evaluating your own models where, you can plug in your own tasks, that whatever you want to use in your study or whatever models, and like recruit participants to use this interface and get a bunch of different metrics out of it. And we, evaluated a bunch of different models in the study with over like, 200 participants, which sounds like a lot already for a user study. And what we see is that like, oh no, the kinds of like gaps in like benchmark performance that we are observing don't necessarily match like the differences in human performance. And we're also observing that, the benefits that people get from models also vary by tasks. So indicating, it's really important to actually have humans in the loop to actually get different insights that you wouldn't necessarily see from just evaluating models on their own. But maybe as you're looking at this list of models that I'm talking about in this paper, you'll notice that none of these models are like, considered, if you, follow on Twitter what people are talking about, like none of these models are like considered state of the art. People don't really use this for code. And so I will move on from this study and talk about like maybe newer things. And, kind of ask like, what's the best way to actually have humans in the loop to do evaluation? Because as I talked about like briefly now, like this was a very nice pipeline to be able to plug in different models, recruit a bunch of users to use these models and get a sense of like how human interaction compares to like static benchmarks. But at each time point, like a user is only interacting with one model. And so while this captures like a fairly realistic usage of these models in practice, it's not really a scalable option in terms of like, yeah.
Sorry, I was just curious, like, could you tell me about like task type? Like, what does that mean? Like, are they, because it kind of seemed like these are like programming interview style questions.
Yeah, so that was kind of the focus of this. We had some, we looked at a very, I guess I did have the bullet point about task type. So we had like algorithmic style tasks, but we had more like what we attempted to make like more realistic versions, though they certainly don't compare to anything that people use in practice. So we like came up with more like data science questions using like pandas or like NumPy and like that kind of thing, where people might actually like those are the more types of things that people do in practice. And then kind of compare that to like more leak code style programming questions. And so,
Okay.
yeah.
Did the task type like change how efficient or how well the models work?
Right. So yeah, that's kind of what we observed in terms of people got quite frustrated with models when trying to do like leak code questions, because if the models were wrong, they were just like very clearly wrong. And so we saw people spend a lot of time like deleting like completions that they thought potentially were useful. Whereas for like data science questions, like it was a little bit easier to get part of the way there with like what the models were recommending and then like make edits on top of that. Oh, I guess you all can get candy later since I did this. Yeah, so yeah, right. The TLDR is yeah, if we wanted to, we could also define more interesting tasks and then try to like have people work on that and get some sense of like, you know, how well are you doing on these tasks with one model versus another. But this is not a super scalable option given that new models are coming out all the time, and we sort of have a limited budget in terms of how many participants we can recruit, and so on. Just to maybe throw out another idea out there, which many of you who are in this or in AI-SDM might be like, oh no, this is like a terrible idea. But I'll be honest, a lot of people are thinking about using LMs as judges, LMs as like, you know, human proxies and so on. So in particular, because they're, you know, cheap, potentially ways to replace collecting actual human judgments and preferences. But, you know, I've also done some work to say like out of the box, it's hard to get models to reflect many different human-like behaviors. So I am not necessarily a proponent of this, but wanted to throw that out there in case somebody was thinking about it. One thing that I think is promising and which I'll spend the rest of this talk on, I did realize this before. Okay. Oh no. This time is wrong. Okay. Which is an alternative way potentially to think about evaluation, and which was built on an existing platform called Chatbot Arena, which I'm not sure how many people have used or heard of, but basically what it is in this form is it's an online website where they host a bunch of different models, and you can, and as the name suggests, it's an arena for chatbots. And so whenever I type in a question, I'll get pairs of responses instead of like in my previous interface where you just have one response, right? Like now you'll randomly get two different models, you don't know what it is. And so if I ask like a question, I'll get these two responses and I can pick like, do I like model A better or model B better, or their ties, where I can ask more questions. So you don't have to vote, but a lot of people do vote because I want to tell you which one I like better. And clearly I've gotten a bunch of votes across like lots and lots of models, and a bunch of people who like actually continue to use this platform. And I think the appeal is largely that people can access like state-of-the-art models for free. So, and I guess people also want to try to like jailbreak or red team these models. And yeah, it's become like increasingly accepted by, or even referenced by, top people in the industry to say like, we deploy, when new Gemini model comes out, they'll put it on this platform first and say like, oh, you got a great score on Chatbot Arena. And related to actual applications like coding, they actually did introduce sort of like a coding category, which they attempt to filter out some of these chat questions for ones that contain code or might be like code related. But while this seems to be fairly scalable in terms of like, they have like millions of votes, it's not super realistic because I personally don't copy all my coding questions into like this online chat platform to be able to, like when I'm working on like real tasks. So existing evaluations are kind of flawed in different ways in terms of, as I just mentioned, this like Chatbot Arena is like very scalable in terms of the number of votes or that we can like models that we can evaluate, but it's not like the most realistic versus, this first platform that I talked about to run the study. I have to go out and recruit all of these like CMU undergrads to participate. So while potentially more realistic, is not all that scalable to keep up with, new model releases. And what we have been working on is something called Copilot Arena as a way to hopefully bridge like both of these like desiderata and like achieve best of both worlds. So what it is you can see as you're typing code, instead of getting one code completion, you'll get two stacked like top bottom. There's also a personal leaderboard if you're interested in that. But yeah, and then the two completions are separated by like these lines. But it is a real extension. So if you're like, wow, I hate Copilot, GitHub Copilot, and I really want to use a free one, even though I don't pay for Copilot, you can feel free to download Copilot Arena in VS Code. And you would get access to, like models that you wouldn't normally have in Copilot. And recently, as of yesterday, we hit 10,000 installs on the VS Code marketplace. So that was pretty exciting. Okay, so what does the actual workflow look like of using Copilot Arena? So given like this is the code that I've written so far, it'll ping our backend server, we'll pick two different models, do some prompting to make sure that like things are formatted correctly, and return to you the two responses from the different models that were sampled, and you can use different keyboard shortcuts to be able to select one or the other. Yeah, and then depending on which one you select, we'll record this information to get to know like which models were being voted on and which one was selected by the user. And maybe just as like a disclaimer, we do have like various levels of like privacy options. So depending on what you're willing to share in terms of like what kind of code you're working on, because we know this is like being used in terms of people's like actual IDs, you can like, choose to not share any of your code with us, and we won't only know, what models you were voting on and so on. But some people are nice and they do share their code. So we can also get a sense of like what people are working on. And in terms of like what kinds of models we evaluate, everything that you might think of and would be interested in potentially to write code with. So I won't go into detail about that. But just as a brief overview, like we have over 10,000 downloads, like there's like 500 people or so using this a day, have like 20,000 like votes and a dozen or so models and more as we continue adding them. But one thing that was cool is like we've even also been able to help evaluate new models before they were launched. So like we evaluated the new like CodeStrol model and the like Mistral CEO like or as part of their like advertising was saying that it did very well on our leaderboard. And you can also view our the Copilot Arena leaderboard anytime if you just go to lmarena.ai. And with these votes, we sort of follow like the same procedure as Chatbot Arena to be able to compute, like how often one model wins versus the other based on like the data that we've collected, and sort of scale up these Bradley coefficients into what they refer to as like an arena score. So this is like a live thing, and it gets like updated every once in a while with like the new votes that have come in. So that part is more interesting for people who are building models and are like, yeah, my model is like on top. But in terms of like from the evaluation and like user perspective, what I was very interested in is looking at, what is this like real world data distribution, as we were just talking about, like with like, coding tasks versus maybe more like data science tasks, like what are people like actually doing in Copilot Arena? And so, for example, looking at programming languages, hopefully it's not too small. We see like a bunch of people are writing code in Python, but there's like kind of a distribution across like all of these other languages. And in fact, there's like 85 more that aren't listed, and many things that I've never heard of, to be honest, but which is pretty cool to see. Also in natural language, like some only contain code, but there's also ones that where people like write comments and such, like in like a bunch of different languages. And in terms of context length, which I think will become interesting in a moment, like we also see like a nice distribution in terms of like how long the code is that people are working on. Maybe this is also of interest, which is we tried to use LMs to classify what kinds of tasks that people are working on while they did not specify. But a lot of people seem to be doing like front end and back end development. There was also code, a much smaller proportion of like code that was classified into like algorithm design. So I think some people were doing more like problems that were akin to like leak coding, but it might also just be other kinds of problems that they were working on. And there's also some like machine learning related things that people are doing in like data processing and so on. So it has like a nice distribution of tasks.
Is context length the length of the file?
Yeah.
Because it's just like doing autocomplete, right? So it's just
Yeah.
like the preceding file.
Something I did not get into detail about is like we also do fill in the middle. So this is like the prefix plus the suffix.
Okay.
Yeah. So yeah, some of these are like insanely long files because I think people don't know how to like separate their code into different files. But yeah, like as you can see here in terms of like completion structures, there are a pretty decent amount of questions where people want to do code completion that like is asking for fill in the middle rather than just like the preceding code. Yeah, and I guess I'll mention like our preprint for Copilot Arena just dropped this morning. So if you're interested in more details, I would recommend you check that out. But we in the paper like find that there's relatively low correlation with a lot of like existing static benchmarks. And so I wanted to just highlight a few potential reasons as to why that might be. And so like the find max example that I showed earlier, a lot of these existing benchmarks evaluate, like Python problems. They're written for like interview coding problems, and they're also written in English, which is quite different from like, the distribution of tasks and programming languages and like natural languages that we have that people actually use in practice. Many of these problems are also like really short. This is also true for many of like chat questions that people write, like, because you only write a short question. You don't have like this like long file of like code that you're working on. And I think like the various like completion structures that are in this code like also are potentially different and very different from that of like existing data sets. Like for example, in terms of the coding problems that are actually classified as coding in Chatbot Arena, only around like 40% of them actually contain code, and many of them don't ask for models to like fill in the middle. And we talked about this a bit more in the paper, but there's also some potentially interesting insights for people who are building code models. So for example, we see a bigger change in terms of user preferences when we stratify by different downstream tasks in comparison to like programming languages. And we also are observing that like smaller models tend to perform better on data that's more similar to static benchmarks, which may not be super surprising, but like it was pretty cool to see that like larger models were a bit more robust to that. Yes. And maybe as like an additional advertisement for why you should try our extension, there's more than just code completions. We also have like editing, code edits. So if you didn't catch that, it's basically you can highlight different pieces of code, write a short prompt of like, oh, fix my like errors or optimize this code or whatever, and you will get similar to this like arena style, 2 different diffs, and you can use shortcuts to pick which ones you want. And then one other related, we're also working on adding chat in, but something else that we've been involved in is doing this thing called repo chat. But I will probably skip this. But yes, if you're interested, please do check out Copilot Arena or follow us on Twitter. We are pretty active. But yeah, in terms of maybe zooming out and thinking about, just beyond looking at coding assistance as like this example that I'm obviously excited about, but I think this is applicable more generally, which is that thinking about how to design evaluations that better reflect real world scenarios like will lead to interesting insights. But obviously this comes with the like challenges of potentially having like it being inefficient or not scalable to have humans in the loop. So thinking about ways to incentivize people to participate in studies is like an interesting question. So that more or less summarizes the different things that I talked about. But as I sort of promised in the beginning, thinking about like agents, for example, navigating the web on the user's behalf, submitting PRs for developers, we will have a new arena coming out at some point about this. I think a lot of the issues that I talked about will continue and will need new and interesting solutions. So for example, thinking about how maybe like existing benchmarks or evaluations of these models like definitely won't reflect how people actually use that in practice. So, I think this will be an interesting direction to work on. And if agents can actually take actions on behalf of users in whatever environments they're working on, I think you also need to think about like what are ways people should be using these kinds of like AI support in ways that will very likely differ from what we have now. Obviously, I wanted to acknowledge my many wonderful collaborators. Yeah. Okay, thanks everyone.
We had a couple questions already, but any questions for our speaker?
Sure.
I think it's about like how you're measuring your task similarity. So like I guess how do you determine whether a task is similar to something a static benchmark data set?
Yeah, we have like a big table about this in the paper, but we try to look at along these different axes that I mentioned, at least that we thought better reflect or that kind of capture like different ways in which you might change. So beyond tasks, like things like programming languages or whatever, like kind of define like what a benchmark looks like. And so those were kind of the features that we were looking at to report how similar or different. And so, for example, like we also grabbed a bunch of like common benchmarks and like measured the distribution of like context lengths to see how like that compares to like the kinds of context length people are working on in our system.
Okay.
Yeah. But yeah, in terms of similarity, we don't actually try to do like a plug two things in and compute how close they are.
Do you also have a sense of who the users of chatbot are? Because I assume the production level code would be different.
all of you ask questions, so.
Yeah, because production level code would be different from maybe what students write for like class assignments or something.
Yeah.
So,
In terms of when actually looking at inspecting some of the code myself, it looks like people are working on like real things. I did see some like homework assignments though, because it was like for whatever class and then like question something and then question another thing. And I was like, oh, I don't know if I feel good about this, but I think the most part is people working on like actual things. And I think that's kind of reflected by like this like big focus on like like front end and back end development. I guess I can give this out later too. I don't know.
There's a question from Tom Malloy. Is it possible for private LLM companies to gain scores on Copilot Arena to vote for their own model? And
Great question. And that there, actually Chatbot Arena recently had a scare because somebody posted on Reddit that they like made thousands of dollars by trying to like game the system. But I think that turned out to be like fake news, but people were scared about that. So I think, I guess you could presumably create like a bot to do this. But in terms of our interface, it takes a little bit of time to actually, like, we don't keep calling like new models or like a new response. Whenever it like needs to be such that like the user has paused and has like written code and then like new completion shows up. So if you're just like waiting there and you're not taking any action, then it doesn't actually, like, it doesn't trigger like our system. So maybe this is like less of the case for Chatbot Arena. Like you could presumably just keep punching in like a new question.
yeah, I noticed that I went to Chatbot Arena while you were
Yeah.
talking here, and it gave a little pop-up that says like, hey, like, give an honest response, because I guess it's feeding it back into.
Yeah. So I guess right now I think just due to the way that the system works, it's a little bit harder, at least for ours, to be able to do that. But that being said, we do pretty carefully inspect like at least the code that we can see to like get a sense of like if anybody, and also each person has a unique like ID. So we try to see like is somebody, voting a bunch or things like that. And but I think this will be important in terms of like this being like an evaluation that many model providers are looking towards. And so, yeah, we want to be ahead of the game in terms of potentially preventing people who want to game the system.
And there's another question on there from John Diaz.
Mm-hmm.
How do you think the interaction between humans and AI can be improved to avoid the snags that came up during the first part of the seminar?
Ooh. I think after my paper on the one where we were talking about understanding explanations came out, a lot of people have done subsequent work on trying to like ways of mitigating like over reliance on explanations. So I think it's a very active area of research. But I feel like my general takeaway from working on all of these applications is they're largely fairly like domain or like use case specific. So I think the best way is to, and I'm sure a lot of people here would resonate with that, is like actually working with like the various like domain experts or end users to like design these tools. Sorry if that was a non-answer.
Do the users actually see like which model is?
Oh yeah, so okay, that's sort of like part of the answer is yes. So once you've made a vote, you can see like this model beat this other model. And a lot of people are interested in seeing like, oh, like the thing I voted on was this model. And it's like part of this like gamification aspect of the system. Yeah. This is also the same for Chatbot Arena, like you reveal afterwards.
Any other questions?
Can we get a quick preview of your agentic arena, at least like what domain you're thinking of?
Oh yeah, so it's still along the lines of code, but if people are working on agents and want to create an arena, let us know. We'd be happy to talk about it. But in terms of the like agent side of things, what I alluded to submitting PRs for developers. And basically what we're looking at right now is if let's say you have issues in your like GitHub repository, and then you can tag like the agent, like, you know, like fix this problem. And then it will call, instead of like one agent to like fix your issue and submit a pull request, we'll actually do two. And so we're working on like an interface for people to review both of the PRs submitted by two different agents. And then like your vote will like, you know, inform like which agent like did a better job solving like the issue that the user wrote.
Okay, cool. Thank you. Yeah, we may connect offline to discuss some more ideas.
Yeah, sounds great. But I know people are working on like web agents and so on. So I think it'll be interesting to finding like what the concrete task is there. Like I think for coding, it's a little bit more specific, but to be able to measure like how well different agents do. So, great. Thank you for all these questions. And for people who are here, do take chocolate.
Let's thank our speaker one more time.